Hi student, today we are going to start the new lecture on engineering mechanics. Okay, my name is Kranthi Bhargav. So I am now dealing with you engineering statics, which is referenced by R.C. HIBBELER. This is the 14th edition. So let's move into the further video. So here, what is engineering mechanics? So, mechanics is a branch of physical sciences that is concerned with the state of rest or motion of bodies that are subjected to action of forces. So, what he is saying is mechanics is only concerned about the state of rest of the motion of the bodies, okay, and the action of the forces on them. Okay, in general, this engineering mechanics is divided into three parts. Okay, so those are rigid body mechanics, deformable body mechanics, and fluid mechanics, right? Now, majorly, according to our syllabus, we are now only concerned with the rigid body mechanics. Okay, so this rigid body mechanics is also now divided into two areas, right? Those two areas are statics and dynamics. Okay, what is statics and what is dynamics? Okay, the statics is nothing but statics is which that deals with the equilibrium of bodies, that is those are the either they are in rest or they are moving in the constant velocity, right? And whereas the dynamics is concerned about the accelerated motion of the bodies. Okay, if a body is there and this body should be in motion and it is having an acceleration. Okay, right. Now there are some fundamental concepts you should have to remember while dealing with the engineering mechanics. So the first point is that particle. Okay, so what is particle actually? Okay, so anything which we are dealing in this engineering mechanic concepts, the particle is a thing which has some mass but the size is neglected, right? It has a mass but the size of it has to be neglected. This is only about the statics. Okay, in the statics the particle has some mass but the size is neglected. For example, there is an earth. Okay, earth, when compared to size of its orbit, the earth is very small, right? So if you want to study the orbital motion of that earth, you need not to worry about the size of the earth. Okay, that is a simple idea. This is a simple basic concept. Well, while we are studying about the basics of the statics, you should remember that you have to consider the body as a particle. Okay, now another one is rigid body. So what is rigid body? A rigid body is considered as a combination of large number of particles. Okay, the rigid body is a combination of all small particles. Okay, those are remain at a fixed distance from one another. Okay, those are a fixed distance. They are combined in a fixed distance. Okay, and they do not deform after applying the load. Okay, these rigid bodies do not deform. Actually, these rigid bodies do not come under the deformation. Okay, those bodies are called as rigid bodies. Now next point is concentrated force. Okay, what is concentrated force? A concentrated force is which the force is applying at a single point of that body. Okay, if you are applying a force on a body, you are assuming that there is a point of contact is only at the single point. Okay, that is which is called as concentrated force. Okay, now as we are going to the basics, there are you should have some basic idea about the Newton laws of motions. Okay, so what are the Newton laws of motions? Okay, so Newton has given our three major laws of the motion, right? As we are studying from the basics of our sixth class onwards, we are studying. So what are those three laws? Okay, why we have to consider these three laws? Okay, in statics these laws plays a very important role in solving the problems, right? So coming to the first law, what he is saying is if a particle is originally at rest. Okay, consider a particle, it is in rest or it is moving in a certain path, okay, with a constant velocity. What happens is, what he states it, the rest body will have to be remain in rest, and the body which is moving in the constant velocity, it has to move in the same velocity until an external force is applied on it. Okay, so for example, if there is a chair in your room, okay, if you left the chair for about 30 years without applying any force, the chair will be remain in the same position. Okay, and if you consider the fan which is rotating in your room, the fan is keeps on rotating, and this fan will not be stopped until you switch off the phone, switch off the switch. Okay, so the fan stops only when you switch off the switch. Okay, that is the basic concept in the first law. Now coming to the second law, what does second law saying? So actually second law gives an idea about the force. Okay, the second law gives the first fundamental concept of force. Okay, the fundamental concept of force is given by the Newton's second law. So what he's saying is, if a particle is acted upon a unbalanced force, there is a force which is acted upon a particle, it gives the force is directly proportional to the acceleration. Okay, the force is directly proportional to the acceleration. If the particle is having some mass m, this is mathematically given as F equals to mass into acceleration, mass time acceleration. We call it mass time acceleration, right? So this is a vector quantity. This force is directly proportional to the acceleration, and the force is equal to mass times acceleration. That's it. So now we are moving to the third law. So what does third law? This third law is very largely applicable law in our world. So what does this third law states? If there are two mutual forces of action and reaction between two particles are equal and opposite and collinear. So according to this statement, what the simple statement, what it is saying is, if there is an equal and opposite reaction, if two for every action there is an equal and opposite reaction, he is saying. So it is simply says that if you apply a force on anything, there should be some external force applied by the thing. Internally it applies, which is nothing but we come to know tomorrow in next lectures. It is known as stress. That force, it is called as internal stress. So this is called an opposite force. Okay, this is a reaction force. Okay, this reaction force is equal and opposite to the force applied, and it is collinear in direction. Okay, it is equal and opposite direction, and it is collinear in line of action, right? That's right. Now Newton's law of gravitational attraction. What is this Newton's law of gravitational attraction actually? So Newton, after giving these three statements, he goes on experimenting, and he found the gravitational attraction between two particles. Okay, he found about the gravitation force, and later on after experimenting, later on so many experiments, he came to know what is the relation between gravitation and two particles acting with a force. Okay, so the force and the gravitational force are mutually given as F equals to universal gravitational constant into m1 into m2 by r square. So what, according to this statement, what it is proving is the force is directly proportional to the mass product of the masses of the particle, and it is inversely proportional to the squares of the distance between them. Okay, squares of the distance between those two particles. That's it, simple. It is a simple concept. So if you see here in this slide, you can find out the value of the capital G, which is nothing but called as a universal constant of gravitation, which is given as 66.73 10 to the power of minus 12 meter cube per kg second square, right? So let's go to another slide. So there are certain important rules when we are dealing with the static problems. Okay, before going to the static problems, you need to know what are the important rules you have to follow. So these are some important rules you can follow. So if you go through this slide, you can find out that a particle has a mass, but as the size is neglected, we already explained it before, and the force is considered as a push or a pull of the body of another. Means a force is always considered as a push or a pull. So similarly, there are some rules has been mentioned in this slide. If you There is a link in this description where you can find this PDF so that you can refer this. Okay, so please go through these important rules so that we can now proceed into the actual lecture of our today's class. So today's class is going to deal with our force vectors. We have to deal with force vectors. Okay, so coming to those, next slide. So we are coming to the actual subject today we are discussing. Okay, today we are discussing about force vectors, right? So what are the vectors? Okay, and here scalars are there. What is scalars? Vectors. Okay, so before you understand this, you need to understand that there are some magnitudes and units you have to determine certain quantities. So quantities are usually divided into two concepts. Those are physical quantities and derived quantities. Okay, so as per physical quantities, you also know that is mass, length and time, and the derived units, these are the combination of these three. Okay, that is simple. So if there is a, for example, there is a thing, a quantity is there is physical quantity which is expressed only by its magnitude, then it is called as scalar. Okay, if there is a physical quantity which is expressed by magnitude and also its direction. Okay, if this quantity is giving you the magnitude and also the direction, then it is called as vector. That's it. This is a fundamental relation between scalars and vectors. Okay, this is the difference which explains the scalars only talk about the magnitude and the vectors both magnitude and direction. That's it. And now moving to the next slide, you can see that we have to talk about what is vector operations. What are some vector operations? Simple. So you know about vectors, right? So as per the before slide, you understand what are vectors. So if there is a particle, okay, if there is a particle and it is some certain forces are applied on it, so we treat the forces of that particle as vectors, since force is a vector. So as vector quantity, force is treated as a vector. So if certain forces are acting on the same particle, okay, if certain forces are acting on the same particle, we need to add those two forces so that we can get the resultant vector. Resultant vector is what? Resultant vector is nothing but the combination of these forces so that we can get the actual resultant of this force. That's it. Two forces are acting on a body and you need to know the resultant vector of the formula. So vector operations are simple. So those are simply vector additions, vector subtractions, vector multiplications and vector divisions. So coming to the vector additions, okay, when there are two vectors and if you want to add those two vectors, okay, there are certain rules you should be followed and thorough. So what are those rules? The fundamental rule is parallelogram law of addition. Okay, so this law is usually used to add two vectors acting on a body. So if there is a particle, if two vectors are acting on that body, so we have to consider that those two forces are treated as adjacent sides of the parallelogram. Okay, two adjacent sides of the parallelogram. Okay, if those two sides, adjacent sides of the parallelogram, are treated as these forces, then so here you can observe the parallelogram law. And similarly, there is another rule which is known as triangle rule. So in this triangle rule, what we are considering is these two forces are considered as two sides of the triangle. Okay, if you consider two sides of the triangle, then the third side, the closing side, will be known as the triangle rule. Okay, will be known as the resultant of those two forces. Okay, the resultant of the two forces is nothing but the closing side of the triangle. That's it. So this triangle rule can be either of a plus b you can write, and b plus a you can also write, okay, as you have shown in b and c diagrams. So there is another special case, okay, there is another special case in which two forces are in collinear, and those are having the same line of action, okay, the line of action of this force is having the same. So what will be the resultant of these two vectors? So these two vectors will have a straight line of resultant having the r equals to directly a plus b. That's it. So you need not to worry about these both triangle and parallelogram here, okay. So similarly there is vector subtraction, okay. The second action we are going is vector subtraction. So what is vector subtraction? This is simple. If you clearly observe that if two forces are applied, okay, one force has to be subtracted. So the subtracted force here in this figure you can see b has to be subtracted. You can simply change the direction. The direction will be denoted will be in minus symbol. So if you see that a minus b can be written as the combination in the addition only, you can simply write as addition. So a plus minus of b, so minus b represents the direction in the opposite direction. That's it, simple. So the minus b has a vector which is having opposite direction, and a can be written as the right side of the parallelogram law. And if you can see here, two representations are have been given. So one is a parallelogram law, and the triangular construction is also given here. So if you see in the figure 2.6 you can see here. So finding resultant of a force, okay, finding resultant of a force. So if two forces, as we are discussing from first class, from the first slide, you have to know how to find the resultant of a force, okay. So the resultant force, for example, in right side you have a figure here, right side you have a figure. So there is a hook which is having two chains which is having, okay, these two chains have a tensions of force 1 and a force 2, okay. These two have different tensions, so these two have a resultant force, okay. In the middle, if you see, there is a middle force which is we treat as resultant force. So how we have to find this resultant force? So already we know the details. So if two forces are acting on a body, for example, if you treat parallelogram law, these two forces are to be applied as two adjacents of a parallelogram law. So parallelogram, there you take a parallelogram and you treat these two forces as two sides of the parallelogram. And if you consider a triangle law, these triangle having those two sides as these forces will be the two sides, and the closing side will be the resultant. That's it. So for example, let us now go to parallelogram law. So these two components, if you see these two forces here divided in u direction, u means what? X direction, x axis, and v is denoted as y axis. So for example, we just considering that. So this is an other axis, okay. This is another representation of different coordinate system, uv coordinate system. So u fu is given in u direction and fv is given in v direction, and these two forces fv and fu are represented as two sides of the parallelogram, and this parallelogram can be reduced into triangle law. So this triangle law, you can see that fu is horizontal and fv is inclined, okay, in v direction, and the closing side force resultant, okay, the closing side which is in blue color in c figure c, you can see that the closing f is the resultant, okay. So if you want to find the resultants, you need to know some of the trigonometry rules. So you need to know some trigonometry. So you can apply sine law, okay. Already people know about the sine law. So the forces acting on a body will be sines of the opposite force will be equal to the sine angle between them. Okay, so if there is a force which will be given as see in the sine law, you can see that if there is a force A, it will be the denoted A by sine A equals to B by sine B equal to C by sine C. So three forces are there. If you consider a triangle having ABC, okay, ABC, so A means one force and B means second force, and C is the closing side, which is nothing but what we said earlier. C is nothing but what happens here, resultant. So the resultant force. So you finally, if you got finally into the triangle, so if two forces are applied on a body and you represent it in the parallelogram form and you reduce into the parallelogram law. So after coming to the parallelogram law and then you again reduce into the triangle law. So by coming into the triangle law, you can apply two rules. One is cosine law and another one is the sine law. So cosine law states what? Cosine law states that the resultant C will be equal to the root over A square. A square means F1 square and B square means F2 square minus 2F1 F2 and cosine angle of C. Okay, cosine angle between those two forces. Okay, that's it, simple. So it is given as cosine law. And coming to the sine law, if you want to find out if you have the triangle but you don't know what are the angles between them, so this sine law will be used very easily so that you can find the angles between them. So you have the A by sine A equals to B by sine B and it's equal to C by sine A. That's it. So let us do a problem so that you can understand this problem and you can today we can wind up this session. Okay, so here there is a problem here. A screw eye. This screw eye is nothing but you can find this hook and this is a screw which is usually used in cellar, okay, on the floor. Okay, so this has been tied with two ropes. Okay, this has been tied with the two ropes and the two ropes are having two tensions, right? F1 is having 100 newtons and F2 is having 150 newtons. So he is asking determine the magnitude and direction of the resultant force. Okay, he is asking, there are two forces acting on a hook or so called as screw eye. So he is asking the resultant force. So he is just asking one force which can represent these two forces. Okay, so you can see here in this problem F1, okay, F1 100 newtons is 15 degrees above the horizontal line. Okay, and 150 newtons F2 150 newtons is 10 degrees inside the y direction. Okay, y axis. Okay, this is simple. Okay, now we moving into the solution, right? So this problem can be simply done like this. Okay, so before doing this problem you need to understand what these two forces are represented in two sides of a parallelogram. So if you represent these two forces of two sides of a parallelogram, you can just now draw a resultant force Fr. Okay, resultant force Fr, and so that you can draw a parallelogram. So using some trigonometry relations, so if already you have known some easily trigonometry, so you have here what x-axis and y-axis having an angle of 90 degrees, right? So both are having 90 degrees. So if you minus 15 degrees and 10 degrees, you will get 65 degrees. Okay, the forces 100 Newton and 150 Newtons are separated with 65 degrees. Okay, and due to this is a parallelogram, the opposite side A here, angle A will be also 65 degrees. Okay, so you have here 265 degrees. So you are having 265 and 65 degrees here. Okay, so if you multiply 265s, you will get how much? 230 degrees. Okay, because the sum of internal angles between parallelogram will be 360 degrees, and if you minus these 65 and 65, you will be left with 230 degrees. And if you want to find only one angle, you have to divide it by 2. So if you divide 230 by 2, you will be left with 115 degrees. Okay, 115 degrees. So you have all the angles and all the directions of this parallelogram, and now we are converting this parallelogram into triangle law. In right side figure, you have just converted this parallelogram into triangle. Okay, so just now you have to apply only the angles. Okay, what we are having is 100 newtons. Okay, F1 and F2 is now moved into right side, and it is will be second force and 150 newtons, and the closing side will be the fr, which is nothing but the resultant. Okay, resultant force. Now we are moving to the solution. So here this parallelogram is formed by so this using parallelogram you have created, and now you completed into triangle law, and using some trigonometric relations you find out the angles. That's it, you completed the angles. So now we are going into the cosine law. So already in previous slides you learned about cosine law. So what will be the cosine law for the fr? The fr will be given as squares of what 150 square and 100 square minus 2 into this f1 and f2 into cosine angle between them. What is the cosine angle between them? It is 115 degrees. So that's it. If you apply the fr here, so if you see the problem here, fr equals to root over 100 Newton square plus 150 Newton square minus 2 into 100 Newton into 150 Newton, and cosine angle between them which is nothing but 115 degrees. And if you reduce the form, if you complete this sum, you will be reduced into, you are getting fr equals to 213 newtons. So this is the answer for this. Okay, 213 newtons is the answer. Now if we are going to find out the direction. Okay, if you want to find out the direction, what is the direction of these two forces? Okay, now we are, before going to the direction, you need to apply laws of sine. So if you apply the sine laws, 150 newtons. Okay, 150 newtons having an angle of theta. Okay, having an angle of theta opposite to that. So 150 newtons divided by sine theta will be equal to what? The resultant. What is the resultant? 213 newtons. So 213 newtons divided by 150 newtons. Okay, 213 newtons will be divided by sine 115 degrees. So if you reduce this equation, you will get sine theta equals to 115 newtons by 213 newtons. Okay, 213 newtons into sine 115 degrees. So if you calculate this, you will be given as theta equals to 39.8 degrees. Okay, 39.8 degrees. So thus the direction here it is represented as what? Phi. Okay, if you see in the figure 2.211, so you have a phi which is the direction. Okay, direction is always given with respect to x-axis. Direction is always given with x-axis. Okay, it is measured from x-axis. So there is a 15 degrees always left here. So in this problem 15 degrees is left. So you got the theta. Okay, you got the theta, and you need to add this theta to this 15 degrees. Okay, so phi will be the sum of 39.8 degrees plus 15 degrees. So the resultant answer will be 54.8 degrees. That's it. That direction will be given as 54.8 degrees. So you got the resultant force and the resultant direction. So this is our example problem. So I hope you understand this problem. So in coming classes we deal with some problems, and we know in depth of these concepts. Okay, so that's all for today. Thank you for following this video. Thank you.